Hello and welcome to my latest update video on Surface Builder. In this video I'm going to show you some of the new updates that were added to 1.03 and 1.04, as well as some things that have changed in order to accommodate new features, and I want to start with those very things. So the first thing you'll notice in 1.04 is when you bring up the Object Properties window, the MIDI message type selection has changed to a traditional pop-up, and that's to accommodate some extra parameters we've added to this. Now you notice we've added two NRN options to the bottom of this list, and also if I select Control Change, you'll notice now we have a new 14-bit button to the right of this control. I'm going to go over these new 14-bit functions in detail later in the video. There's just one other thing that's changed from the last version, and that's the LFO function that we can attach to a button. Now if you look at the LFO function, you'll see that there's now additional parameters in here. Now although we had the 14-bit button in a previous version of Surface Builder, we've now added to that and added the NRN options to the drop-down list here. So we can send either 7 or 14-bit NRN as well as standard controllers. But for now I want to turn our attention to some new features that we've added, including the Scene tab bar. Now we've got plenty of ways of changing between scenes, including actually having dedicated buttons which we can add to our surface, which can change scene, and we've also got the toolbar button which can do the same. But now we've added a new method of changing scene, which involves turning on the tab bar, which can be found in Settings. So if we tell it to show scene tab bar, you'll see at the top of the screen now we have these tabs, which even work in presentation mode. I double tap there to change to presentation mode, and as you can see, if I tap on these tabs at the top of the screen, we change scene that way. Now this is a persistent function, and when turned on it will remain on screen throughout loading of various surfaces. But what you can do is you can double tap on a tab to actually name it, and that is saved as part of the surface. So all your tab names are saved as part of the surface, but the tab bar itself will remain constant, and to remove it you've got to physically turn it off. So now I want to move on to audio clips, and I know a lot of you are using these and wanting new functionality, and I'm going to go over some of the things we've done to audio clips to improve the way they work. In the previous version we introduced queued audio, and if we take a look at this surface here and look at the object properties, you'll see that the first two buttons in this drum pads surface are both queued audio. All the others are just simply one-shots. Now if I exit edit mode and just swipe down on that first button, you'll notice that that bass drum button is actually set to repeat. And what that means, when we press this queued audio button, it will repeat constantly, and when we tap that button again it stops playback. Now the second button, the snare drum, when I tap on that it just plays all the way through and stops because repeat is not set. Now the other thing to know is a queued audio on repeat will just carry on regardless, even if I play all these one shots. But when I play another piece of queued audio, it will queue up, and as soon as the bass drum finishes its loop, the next queued piece will start. In other words, it caused the bass drum to exit its repeat cycle. Now I'm sure you've noticed the three knobs we have under here, which are all labelled up as reverb. And if we take a look at each of them, they're connected to various knob functions, reverb mix, reverb color, and reverb size. And we've added a basic reverb to Surface Builder, and that affects any audio clips you play, or any audio passing through Surface Builder. So if it's loaded as an effect, then it will affect anything passing through. Another object that's been upgraded is the XY pad, and we've added a new glide function to that. So let me show you how that works. Now, traditionally, wherever we tap on the XY pad, the little target moves to our finger position. I've got auto centering on that particular XY pad. I've turned the centering off on this one. You can see wherever I tap and move my finger, the target follows, but it follows instantly. Now if we go into the object properties and click on the function data, we can turn on the glide function, and whenever we tap anywhere within this pad, the target will follow, but it will follow at a glide speed, which can be changed. It can become faster, or we can slow it right down if need be, to a snail pace. And the great thing is it kind of follows your finger, so if I want to move around, it ensures a constant velocity. But as you can see, it's got an ease in and ease out, so that it's not so dramatic. Now looking at the right pad, the yellow pad, it has auto centering enabled, so it glides into position when we touch the pad, and then it glides back when I release my finger. Now I know some people have requested that we can turn off the little pop-up feedback that appears whenever we adjust a XY pad or a knob or a slide and so on. We can turn on this disable feedback option within settings, and once that's turned on, we do not get these little pop-ups appear. Now another object that has some changes in 1.04 is the stepper object, and this object is useful for sending something like CC values to a destination synth. Maybe it's to change a patch, maybe it's to change a volume level or whatever. Now if we click the left and right arrows, we can increment and decrement the value, but if we hold down, say, this right arrow, it will speed up and we can very quickly get to where we want to be. That's great for 7-bit values, not so great for 14-bit values, which I'm going to show you later. Now if you tap in the center and then swipe left or right, it will jump in blocks. I think of 16 at this point because we're a 7-bit value. As soon as we go to 14-bit values, we'll jump in several K at a time. And also we can double tap on one of these steppers now and enter an exact number we want to go to. Now the majority of work that's gone into this 1.04 upgrade was to add things like 7 and 14-bit NRN support. Now back in the early 80s, there was a whole bunch of synthesizers available that had no MIDI whatsoever, and I had one of these Yamaha CSs at the time. Very good synth though it was, it would only use CV gate, and it took a few years before a lot of these well-known classic synthesizers started to incorporate MIDI. Now this was in the days when 8-bit computers were the thing. So if you remember the VIC-20 and the Commodore 64 and the BBC Micro, all these were 8-bit devices. So eventually manufacturers started to introduce MIDI into their synthesizers, and because 8-bit was all the rage, we now have a pretty antiquated system that relies on this 8-bit technology. A MIDI message usually is 2 or 3 8-bit bytes in sequence, with a status byte followed by multiple data bytes. And the status byte always starts with a 1, and a data byte always starts with a 0, leaving 7 bits of data left for describing a message. Now, because we're working in binary, those 7 remaining bits can specify a number from 0 to 127. Now, the status byte tells us the type of message, i.e. note on, note off, and the channel number from 1 to 16. Now, if the status byte was describing a note on, there will be 2 data bytes, the first giving the note number from 0 to 127 and the second giving the velocity from 0 to 127. Now, if we go back to the status byte, you'll see that there's only 3 bits available for the MIDI message and 4 bits available for the MIDI number. So the MIDI channel number is a value in the range of 0 to 15, hence you've got 16 MIDI channels available. So essentially each MIDI connection could carry 16 channels of MIDI. And the 4 bits that were available for the message we're specifying things like note off, note on, polyphonic aftertouch, control change, which we're going to come to, program change, channel aftertouch, and pitch bend change. So as we mentioned previously, the note on message consists of 3 bytes of data. The first byte specifying the type of message and the MIDI channel from 0 to 16. The second byte explained to us which note was being pressed, and that ranges from 0 to 127. If you look at most 8-octave keyboards, they have less notes than that. And the third byte was the actual velocity at which that note was being pressed. Now you should notice here that this 127 is a number that repeats constantly throughout all the MIDI messages, and while it's simple to understand, it does lead to various issues, especially when we're looking at controller changes. Now, controller number 1 is the modulation wheel. So if we take a look at the data, the first byte of data specifies controller change and the channel. The second byte describes the controller number, i.e. 1 for modulation, and the third value specifies a value from 0 to 127. Now if we return to Surface Builder, you'll see I've got a surface here with a couple of faders and a few knobs, and you'll notice one thing when you play around with Surface Builder, that is that by default all the values go from 0 to 127, and I think we now know why that is the case, and that's because the MIDI standard only allows us to send messages with values of 0 to 127. Now, although we can modify the minimum and maximum values in here, it does not change the fact that we have a limited number of values we can send to control something, and this becomes a problem when we want precision. Now, by extending 7-bit to 14-bit, we vastly increase the number of individual values we can send to a device. Now, of course, I can click on that knob, and typically we want to set this up to send control changes, but you've noticed now that there's a 14-bit button to the right of that button I just pressed, the message button. If I enable that and hit the save button, you should immediately notice that the value for the position of that knob has changed. It's now got fractional part to it, which means that knob has 10 times more resolution than it previously had. Now, whenever we enable 14-bit mode any of the 14-bit modes, these interface elements will flick into high definition mode and will start outputting more resolution. Obviously, one way of getting more resolution is to increase the size of the fader, but as you can see here, once in 14-bit mode, they actually the interface elements give more precision. Now I want to take a look at what is actually happening now behind the scenes, because just by enabling that 14-bit button, how does that affect the messages and how the messages are sent? So the best way, as always, to look at what's being output is to go to the main menu and then go to the Windows, Show Windows, and pick the MIDI monitor. Now the MIDI monitor window will show everything that's been input or output. Now I'm going to turn off the 14-bit option for that fader so that we can actually take a look at the values that are being output currently. And you'll notice the values between 0 and 127. And we're currently sending controller 7, which I think is pan or volume, one or the other. Now when I enable 14-bit mode, watch what happens. You'll notice the values now range from 0 up to 16383. Now that is a 14-bit number. That's the largest 14-bit number that we can have. And notice also that the controller output is now 7 plus 39. Now the MIDI specification specifies a number of controllers which are split into two 7-bit values, most significant bit and least significant bit, and they are usually spaced 32 apart. So by enabling this 14-bit mode, what we're actually doing here is we're actually transmitting two controller values, one for the most significant bit, which would be on, in this case, on 12, and then the least significant bit is being transmitted on 44. So great, the 14-bit mode has solved the problem of precision, but what happens if a device wants to have more than 127 controllers? It might be a hardware sensor with tons of built-in features, and you might want to be able to control thousands of parameters using a single MIDI message, and that's where NRN comes in. Now to see this in action, we're best just clicking on the knob here, open up the object properties and selecting NRN 7-bit for a start. You'll notice, the first thing you should notice is a new knob appeared in this list. Now this is because instead of just using a 1cc value from 0 to 127, we now use two, a most significant bit and a least significant bit, and together they'll address 16,384 different combinations. Now because we selected the 7-bit variant, the values as expected go from 0 to 127. The difference here is that we can address more different properties of a hardware synth. And if we change that to NRN 14-bit, you'll see that this time we get the full range of 0 to 16383. So that gives us the precision we need and access to over 16,000 properties of a piece of hardware. Now to see this in action, I've got a split screen here of Surface Builder and MIDI Designer Pro, and I'm going to ensure that my port is mapped correctly, and both of these knobs in each app are mapped equally using NRN 16-bit. And you can see by me changing the knob in Surface Builder, we get a nice smooth transition and if we change the values inside Designer Pro, it changes the values in Surface Builder. And you can always use the MIDI learn function, so if I enable that for that knob here and change the knob in Designer Pro, you see it immediately picks up on that NRN 16 value coming in. I also want you to notice that when we're in design mode, if I select a different element, object, the MIDI signal coming in highlights the relevant object associated with that incoming data. So that just about wraps up this video. Hopefully you'll subscribe to the channel if you haven't already done so, and thumb up the video, and I will see you next time. Thanks for watching.